Hey guys, this video is going to be over the Bronsted Lowry conjugate acid-base pair, so determining which one is the acid, the base, the conjugate acid, the conjugate base, and finding the conjugate acid or base from the acid or base. Alright, so before we do that, I want to make sure everybody understands what hydrogen ion is, and so a hydrogen ion, a hydrogen atom is one proton and one electron. Whoa, wrong thing. Okay, so if it becomes H+, that means it's lost an electron. We did this at the beginning of the year, so it's been a while, but you should still understand negatives and positives. So if it's lost an electron, then this is just a proton. So sometimes with acids and bases, they refer to hydrogen ions as protons. All it is a hydrogen ion, so don't get confused by that. Okay, so Bronsted Lowry definitions. Acids lose protons and bases gain protons. So if I look at this reaction right here, this is an acid-base reaction. This, we look at it on the left side, on the reactant side, and if we look at it on the product side, it has gained a hydrogen. Right? So we have NH3 here, and then it has NH4 here, so it's gained a proton. So that means that NH3 is a base because it gained. So water here, we look at that on this side of the reaction, and then we look at it over here, it's lost a proton. So that means this is an acid. Okay? Now, with Bronsted Lowry acids and bases, we can look at the other side of the reaction and determine what it is. So if I look on this side, NH4 turns into NH3, and so it's losing a proton. So we call that the conjugate acid. And then hydroxide, if we look at that one, hydroxide started here and then it went over here and turned into water, so it gained an hydrogen, so that's the conjugate base. Now, the way that this works is the base is going to turn into the conjugate acid, and so these are acid-base pairs. So a base will always turn into a conjugate acid, and an acid will always turn into a conjugate base. And so this is also an acid-base pair. Okay? Now, if we wanted to write that down in words, the way that I would say it would be the acid loses a proton and becomes, a conjugate base, and then the base gains a proton and becomes a conjugate acid. All right, so another way to say it would be conjugate acids are acids in the reverse reaction, and conjugate bases are bases in the reverse reaction. So if we go back and look at all of this, okay? So NH3 is the base because it gains a proton, and it becomes the conjugate acid. Also looking in reverse, NH4 loses the proton, and so it is an acid, it's the conjugate acid of this base. Similarly for water, water is losing a proton, so it's an acid, and hydroxide in reverse is gaining a proton, so it's a base. It's the conjugate base of the water. All right. Okay, so here's some examples. We need to label the acid, the base, the conjugate acid, and the conjugate base. So this first one right here, I'm going to look and find its pair on the other side. So hydrogen carbonate, if I look over here, it becomes carbonate. It has lost a hydrogen, so that means it's an acid, and acids form conjugate bases. Okay, that's its pair, the conjugate base. And then this is going to be, if we look and see what happens to it, it's gained a hydrogen, so that means it's the base, and it forms the conjugate acid. All right, we have hydrochloric acid here, so I'm going to find its pair, and it's right here. So it's going to lose hydrogen, means that it's the acid. Of course, it's the acid, it's hydrochloric acid. It's not going to be anything but an acid. And water gains the hydrogen that hydrochloric acid gave away, so it is the base. Water, since it's the base, this will be its conjugate acid, because if we look in the reverse direction, it loses, and that's the definition of an acid. It's going to lose hydrogen. Also, chlorine will be the conjugate base. Chloride will be the conjugate base. All right, so this last example down here, we have this compound, right? And if we look over here, it's gained a hydrogen. There's an extra hydrogen down here, H+. So this is going to be the base, which means this is its conjugate acid. And water right here has turned into hydroxide, so it's lost. So this is the acid, and hydroxide is the conjugate base. All right, next it says, what is the conjugate base that would be formed from the following acids? So if these are acids, acids lose hydrogen, lose the proton, right, the hydrogen ion, to become a conjugate base. So if it loses one of these, it's going to become HPO4, and if it loses H+, then since it was already -1, it's going to become -2, or 2-. All right, and then we have this. Okay, and it's supposed to be an acid, so it's going to lose a hydrogen, which means one of these hydrogens is going to come off. I'm going to pull off the last one here. And so we would write it like that. Okay, now with acids, it doesn't matter which hydrogen you pull off, you just can't pull them off from the middle of the compound. So if you had that is an acid. If you had that, you wouldn't pull these off. You could only pull this one off. One of those. All right. What is the conjugate acid that would be formed from the following bases? So we have fluoride is the first one. Now bases, what do? They gain H+. So we're going to add an H+ to this. So it would be HF. And it had a negative charge, and we added a positive charge to that, and a positive and negative make it neutral. Okay? So, and then with water, we're going to add an H+ to it, and so it's going to end up becoming H3O+. All right, that's it. This is pretty simple if you just make sure that you know what an acid and a base is, and everything else should fall in line. So bases gain protons and acids lose protons.